All right, here we go. Unit 5, Lesson 5. Today we're going to be working on additional powers of I, the imaginary unit. So remember, we defined I, basically its whole reason to exist is that I is the number that solves the equation I squared equals -1. And so it's a made up number that if you were to square it would give you -1. The implication of that we've mostly used is that if you took the square root of both sides, right, you're allowed to do anything to an equation as long as you do it to both sides, you get I is equal to the square root of -1. So we know what I is, and we know what I squared is. But what about I to the third, I to the fourth, I to the fifth, I to the 120th? Okay, so if we apply our exponent rules, remember if you have like x to the a times x to the b, if we multiply two bases together, two of the same base with different exponents, we would add their exponents. So like x cubed times x to the fourth would be x to the seventh because it's 7x's being multiplied together. And so let's take a look at I to the third. Well, I to the third, if I think about it, is I squared times one more I. And since I squared is -1, this is just going to be -I. I to the fourth is I squared times I squared. -1 times -1 would be equal to 1. So that's probably the first really interesting result, is that I to the fourth, right, is the same thing as the number 1. And so we've got basically two really important tricks we can use. If we know that I to the fourth is 1, and we know that I squared equals -1, we can quickly figure out any additional powers of I. So like what's I to the fifth? Well, it's I to the fourth, which is 1 times one more I. Oh, I to the fifth is just the same thing as I, right? That's pretty cool. I to the fifth and I are the same number. What about I to the sixth? Well, that would be I to the fourth times I squared. 1 times -1. Whoa, I to the sixth is -1. And this goes on and on and on like this. So like I to the seventh, right? We could think about that like, okay, that's I to the fourth times I squared times one more I. Well, that's 1 times -1 times I. This is going to be -I. And we keep going like this. I to the eighth is I to the fourth times I to the fourth. And we get here, 1 times 1 is 1. And we start to notice this pattern. Check this out. We have -I. Then we have, and I'll do this in color so you can see the pattern. Then we have 1. Then we have I. Then we have -1. Sorry, I was trying to do that a different color. Then we have, let's do that one in black. Then we have -1. Then we're back to -I. Then we're back to 1. And it turns out we end up cycling through this pattern, right? We end up cycling through this pattern, and the way the pattern goes is 1, because I to the 0 is 1. I squared is -1. I to the third is -I. Then I to the fourth is 1. Then I to the fifth is I. And then I to the sixth is -1. And this goes on and on and on forever. It just repeats in blocks of 4. And so if we can just look at this and we can say, okay, this is I to the 0, I to the 1, I to the 2, I to the third, and I to the fourth, every power of 4 will be 1. So I to the 12th, since that's I to the fourth times I to the fourth times I to the fourth, that's all 1s. That's going to be 1. And then I to the 21st is I to the fourth times itself 5 times. 1, 2, 3, 4, 5. That's I to the 20th times 1 more I. So we get I. I to the 403rd is I to the fourth times itself 100 times, right? It's 100 1s all multiplied together times I squared, that gets us to 402, times I. And so all that's going to matter here is 1 times -1 times I. This is equal to negative I. So you can figure out here sort of any power of I by really just honing in on the fact that I to the fourth is -1 and counting around from there. Okay, so that's the key point here. There are only 4 possible powers of I, -1, -I, and 1. They repeat over and over and over again, and any power that's divisible by 4 will be 1. And you can go from there. There is a fun geometric intuition to this. So here's the geometric intuition, and then I'll show you what this looks like on the delta math. Okay, like I said before, just to see this one more time, I to the 0, right? Anything to the 0 power is 1, right? That's just a mathematical fact. Anything to the 0 power is 1. And so this right here, if you were to imagine this is your complex plane, remember you got your real numbers and you got your imaginary numbers. I to the 0 is right here. If we multiply I to the 0 times I, well, we'd wind up right here. So we'd have I. I to the first is I. Then we have I squared. Well, I squared is -1. And then we'd have I to the third. Well, so let's do that there. I squared is -1. Then we'd have I to the third is -I, as we showed before. And so it's right there. And now here's where it starts to really click. If we go around again, I to the fourth, since it's I squared times I squared, since it's -1 times -1, is back to 1. So this is I to the 0, I to the fourth, and you can kind of see how this is going. I to the fifth will be 1 times 1 more I. Now we're going to have I to the fifth. And then we're going to have I to the sixth is 3 -1s times each other. So this is going to be -1. And so you can see that this just goes on, right? Now once I have like faith in the fact that this works, I know that I to the seventh is going to be -I. And we're going to go around and around and around like this, right? I to the eighth is a power of 4. So this is 1. And so the idea is basically you can keep filling this out. Every time you multiply by I, you rotate 90 degrees. You rotate 90 degrees around the imaginary plane, around and around and around again. So I to the ninth, right, we'll just keep going here, finish this off. I to the ninth would be here, and so that would be I. I to the 10th would be 5 -1s times each other, so this is going to be -I. I to the 11th is going to be down there with the I to the third and the I to the seventh. So it's going to be -I, and then I to the 12th back to where we started. So it's the circle of life. It goes around and around and around again. So that's pretty much it for today. I'm going to pull up like a big version of this so you can see there's one Desmos activity that asks you to do this really fast, and I just want to kind of demo what that would look like here. So this is basically going to give me powers of I and ask me pretty quickly to figure out. Remember, there's only 4 possibilities. The 4 possibilities are 1, I, -I, and 1I, -1, and -I. All right, so let's see what this would look like. So the objective here is to see how many you can get in 100 seconds. I'll set it slightly differently for yours. Okay, I to the 27th. So here's the strategy here. I like to just always think about, right, you could sit there and you could say, okay, this is I squared times I squared times I squared, or I to the fourth times I to the fourth times I to the fourth. You could sit there and count a whole bunch of these out, but the easiest thing to do is to just think to yourself, okay, what's the closest thing? Oh yeah, 28 divided by 4 is 7. So this right here would be I to the 28th. And so if I go backwards, right, this thing usually goes around the circle counterclockwise when we multiply. This would be I to the 27th here, and so this is going to be -I. Okay, so that's going to be -I. Oh, okay, well this one, see, this is how I can start to go really fast. This one, I don't know why it's doing that there. I don't need to look that up. I to the 26th would be just right here. It would be 1 more back, so this would be -1. I to the 36th, well 36 is divisible by 4. So I to the 36th is just 1. 51, well, I to the 52nd, so you're going to get really good powers of 2, is divisible by, the power is divisible by 4. So we're going to be right back here at I to the 51st is going to be negative I. I to the 32nd, 32 is divisible by 4, so that'll be right here next to the 28. So that's going to be 1. The 50th will be 1 back from the 51st, so this will be I to the 50th right here will be negative 1. The 71st, okay, well 72 is divisible by 4, so this is going to be 1 back here. This is going to be I to the 71st is going to be at negative I. Ooh, 174. That's a tricky one, so let's see. 100 is divisible by 4, 140 is divisible by 4, 160, 164, 168. So 172 is right there, and so we're going to have to go 2 back from that. I to the 170 is right here at negative 1. I to the 50th, oh, we already did that one. That's negative 1. 152, that's divisible by 4, so that's going to be a 1. And yeah, so I got it under 100 seconds there. So that's weird. We never did one that was a plus I. But that's how you can do those quickly. The easiest way to do it is just really use the circle to conceptualize. Remember, all of the I to the 4th, I to the 8th, etc. powers will be at positive 1.